This is one of the quiz questions that I did in the informed search lecture, and I think I was not very clear about how to deal with repeated nodes in a queue, so I want to clarify it here. And I will talk about both approaches. First, keep the repeated nodes in the queue, which is what we're doing this year, and by default we'll do this for the homework and the exams. And I will also talk about what I did last year, which is somehow we can recombine those nodes in the queue if they are repeated. In any case, I will use this example here. Suppose we have the diagram already, and we will start with the queue. And we need to keep track of G here. If we are using A star, we just keep track of HG and H plus 3. So in any case, I will start from the beginning, and at the beginning there is only the initial node, 1, and the G so far is 0. And the next step is to dequeue the node with the smallest G and then enqueue the successors. So the successors include 2, 3, 4, and 5. So we need to keep track of where they came from as a subscript. So 2, 3, 4, and 5. And their costs are 1, 2, 4, and 8. And next step is find the node with the smallest G, which is 1 here, and then dequeue this and enqueue the successors. And the successors of 2 can be 3, 4, and 5. So 3 from 2, 4 from 2, and 5 from 2. So now we need to add 1 to all of the costs between 2, 3, 2, 4, and 2, 5. So it's 1 plus 1, so 2. And 2 to 4 is 1 plus 2, so 3, and 1 plus 4 is 5. And then next, the smallest one is 3, and they're both 3, so I will use the tie-breaking rule that says we dequeue the one with the smaller index, so it came from 1, so I will dequeue this one first, and we'll enqueue the successors. The successors are 5, 4, and 5 from 3. So we have 2 already, so it's 2 plus 1 and 2 plus 2. So 3 and 4. So next we dequeue this, which is also 2. And when we enqueue 4 and 5, they are exactly the same. So 3 and 4. So now you can probably see why this algorithm is kind of inefficient, because we are repeatedly dequeuing the same thing multiple times and enqueuing exactly the same nodes at the end. So we'll do a lot of work to dequeue all of these things, these repeated things again. So next, we need to dequeue the 3s. So we need to dequeue this one first, and it will be 5 from 4, and it's 3 plus 4 to 5 is 1, so it's 4, and we'll also dequeue this one and this one, so we'll add another 2. Okay, so next, we're done with all the 3s, so we start with the 4s, and the first one is 4 from 1, and then we will add yet another 5 from 4, and let me just do it here, and now it's 5 because it's 4 plus 1, and finally we are left with only the 5s, and now we dequeue the 5 with the smallest subscript and also the smallest G. So now we have this. And I didn't keep track of the things that we expanded, but it's basically start from 1. Let's see, 1, 2, 3, 3. And how many 4s we dequeued? 4, 4, 4, and another 4. So there are 4 4s, and then at the end 5. And 5 is the goal state, so we stop. So that's what we did in the lecture this year. And I also want to talk about what we did last year, which if you want to implement this algorithm, you should do that because that's a lot more efficient. But you need to implement it more carefully. So let's start from the queue again. And we start with 1, and then we DQ 1. So at the beginning, it's exactly the same. 0, 1, 2, 4, and 8. So the next step, when you DQ 2, you want to enqueue 3 from 2, 4 from 2, and 5 from 2, which they all exist in the queue already. So we need to combine them somehow. And here the new one is 3 from 2 is 2, so it's the same. So we have a 3 from 2, which is also 2, so we will just not enqueue it. And 4 from 2 is actually 1 plus 2 is 3, so I will remove this and update it to 4 from 2 and update this to 3. So that's what I mean by not keeping repeated nodes in the queue. And next, 5 from 2 is 5, so I will update this 5 from 2 and make it 5. So you can probably see what we'll do next. 3 is 2, so we'll get rid of the 3 and enqueue 4 from 3. And what's 4 from 3? 2 plus 1, which is also 3, so we didn't do anything, so I'll just get rid of the new one. And 5 from 3, I think 5 from 3 is 4, right? 2 plus 2 is 4, so we'll update this and get rid of the old one. So now we'll do the last step, and we will DQ this 4, and we will enqueue 5 from 4, and 5 from 4 is 3 plus 1, which is also 4, so we don't enqueue this 5 from 4, so we keep this 5 from 3 with the cost of 4, then we're done. So the last step is just get rid of this. So let's see what we have done. 1, 2, 3, 4, and 5. So that's the list of things expanded, which, as you can see, is efficient. But the problem is we need to deal with how to recombine these things. There are additional tie-breaking rules that we need to somehow to deal with when we implement this. But as I said earlier, if you see a question like this on the exam, I will ask you to assume we can keep the repeated nodes in the queue.